Welcome back, everybody. Today we're bringing back the LEGO RC car. We're doing some drivetrain updates, some steering updates, as well as putting our new IR timing system to the test with some drag racing. On the previous part of the LEGO RC build, there was a lot of challenges getting these gears to line up. The DC motor in this gear was okay, but this gear on the end here did not stay very well and kept slipping. So now we're going to eliminate that problem. I've designed a new 3D printed housing for this motor. This will just mount inside there. And then I've also 3D printed a corresponding gear that will mesh with this RC motor and also connect with our LEGO parts. Let's start up the motor and see if it works. A little update here on the LEGO car build. I've got the back half of the car put together here. You can see the DC motor mounted with the 3D printed gear here. I've tried to keep the assembly pretty simple so we can keep it as lightweight as possible. So as you notice here, a lot of the gear connections here, from this small gear to this large gear, I actually have it doubled up. So there's two small gears and two large gears. I found when I was building this, if I didn't have those doubled up, the power was too much for these LEGO gears and these would start to slip. So unfortunately I had to double up these gears and double up these gears too. I would like to take a minute and talk about the gearing and the theoretical top speed of these cars. So starting off with the original LEGO car from the first video, there's three components to calculate the speed. I have the motor RPM of the DC motor, the gear ratio that's geared down to, and then basically the tire circumference. And then we multiply that all out. So that's 822 meters per minute, or about 50 kilometers per hour. And then moving on to the LEGO car number 1 build, we can have those three same components, the motor RPM, the gear ratio, and the tire circumference. So multiplying that all out in the same way, we get about 69 kilometers per hour. So this is a much higher top speed or much lower gearing, which would also equate to some lower acceleration. That may be one reason why in the first video the LEGO car was much slower than the original RC car. And now moving on to what we're building now with LEGO car round 2. So multiplying that all out is 1,083 meters per minute, or about 65 kilometers per hour. Almost the same as the previous one, but we'll see how that goes. We do have a couple things we can change if we want to lower that and potentially increase the acceleration. Now I have the rest of the car put together, have front wheels put on it, we have steering, controller, battery, everything in place. It is quite ugly. I know these wheels are not aligned, they're shifted a bit, but that's how it looks. We're going to use that just for function testing and see how it works. And the weight of this right now is about 685 grams. Okay, let's try a trial run at partial throttle. 1.73. All right, let's see if we can go a little bit faster. Oh. All right, we got some serious front end and steering issues to address. So one of the major contributions to this steering issue is that everything is so loose. So even though the steering motor is not moving, there's so much movement here. Part of it is the fitment into this hole. Part of it is the steering motor itself not being mounted solid. And part of it is the play in these wheels on the left and right. So let's see if we can tighten those up a bit. The other major issue with this is if this car impacts just about anything, this whole front end just comes apart, and it's really just not put together or designed that well. So I'm going to maybe do a complete redesign of this front end, fix these issues. For these wheel spindles that the wheels are mounted to onto the car, they are quite loose and there's quite a lot of play that was causing some of the issue we're having with the steering. So I've taken this apart on this piece and I've added basically layers of masking tape to make a washer. The spindle is now tightened up significantly and it still spins freely. So this is going to be a good improvement on the steering. For the steering servo motor, there's a little ball at the end here that is fitting into some holes on these Lego pieces to control the steering. Right now that's pretty loose and that's what's causing some of that play. I'm going to try and put some masking tape around this and see if that can help tighten it up. Looks like that got rid of most of the play, so that's going to be a huge improvement. Before, I had this steering motor mounted in with sort of a triangular bracket on top that didn't hold it very tight. So I was able to take these mounting flanges and trim them a little bit, and then basically put this Lego piece right in there, like so, and that fits really, really tight. So that should be a huge improvement as well. Okay, now we've improved the front steering and it's tightened up significantly. There's not play like it used to be. Now I've got the front end completely rebuilt and put back together. It no longer falls apart upon impact, so that's positive. Let's see the weight difference. About 667 grams. So let's take this and let's go to the racetrack and see how fast it is. Ooh, 1.98, not bad.
Smoking.